I welcome you all to today's discussion, wherein we'll be taking up a question from one of the areas which is feared the most by the students. It is permutation and combination. So I have a question that I have selected from permutation combination of CAT level difficulty, because these models of questions have also appeared in the previous year CAT papers. So that will help us also brush up our basics if you are already done with this concept, or learn it afresh if you have not done this concept. But just like any other video, the first thing I would like all of you to do is please give this question a try, okay? And then we shall start the discussion. You can pause the video, try it for 2 to 3 minutes, and then resume watching. So I would anyways be starting the discussion here. It says there are 3 non-identical boxes. So non-identical would mean he is intending to tell us distinct. So let's say the boxes are, one is box 1, box 2, box 3. And then he says there are 15 identical balls to be placed in them. So let's say the balls are small b's and they are 15 in numbers. If the first box, that is B1, should contain at least 2 balls. So B1 should have at least 2 balls. The second one, B2, should have at least 3. And the third one should have at least 5. Find the number of ways in which the balls can be placed in this 3 boxes. Now, this is the question which involves identical elements to be placed into distinct boxes. So it's similar to, we have a question type in our permutation combination wherein we are posting letters. So this case is similar to posting 15 identical letters into 3 boxes, post boxes, right, which are distinct, such that the first box should have 2 letters, the second should have 3 letters, and so on. Very, very similar to that. Now, how do we solve it? Now, for understanding this question, how do we go about it? There is a formula that we can recall if you know it already, or let's look at the reasoning behind the formula. Look at this, please. Let us say you have some k variables, x1 to xk, which add up to n. Right? The value is becoming n. Right? All these are whole numbers, let's say. Right? x1, x2, xk are whole numbers. Now, when I say whole numbers, that means here x1, x2, so on till xk are greater than or equal to 0 also. They are not necessarily positive always. They could be 0 also. Now, in this case, what will be the number of solutions for this equation? So, what will be the number of solutions for this equation? How do we calculate it? Is, look at this. Now, imagine this. These x1, x2, x3, they are all distinct variables, right? I can differentiate between x1 and x3. This getting 3 and this getting 2 is different from this getting 2 and this getting 3. They are 2 different cases. We can differentiate. So let's think about it this way. This is equal to n. So let's assume this is n identical objects. So let's say there are some n rings or balls that we are placing here, like this, n number. Okay, and now please understand, I need to divide this string of n identical objects into k parts. So for example, if I take a numerical value, observe this, if I take x1 plus x2 equal to 10 as a discussion point, I have 10 identical objects, 10. Now my job is to divide this string of 10 objects, identical objects, into 2 pieces, 2 parts. Now the way to do it is placing some partitions, or you can simply cut this string. Right? So let's take the case of placing partitions. So imagine if I place a partition here, then what I would say, or what I would think is, the string to the left is going to x1, string to the right is going to x2. So that way we are able to divide the 10 into 2 parts, whole numbers. If I place the partition here, string to the left, that is 1, is going to x1, 9 is going to x2. If I place the partition here, then string to the left, which is 0, is going to x1, everything is going to x2. So this way, as I shift the position of partition, can I say I will get different solutions? For example, if I place the partition here, I'll get 5 and 5 solution, 5, 5. If I place the partition here, I'll get 9, 1. If I place the partition here, I'll get 0, 10, and so on and so forth. As I change the position of the partition, my solution set will also keep on changing. So can we all agree? Number of ways in which I can arrange these elements. There are 11 elements overall. Number of ways in which I can arrange these 11 elements. Or another way of saying this is, see, here when I place this 10 items, identical items, there are some spaces which are created. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. And can I say partition can be placed in any one of these 11 places? We can place those partitions at any of the 11 places, right? So in how many ways can we do it? We could say it's 11 C1 because I have to place one partition. Or another way is, as I was saying, I need to arrange 11 items, 10 identical objects and one partition. We have to arrange 11 items out of which 10 are identical. In how many ways can I do it? 11 factorial by 10 factorial, which is nothing but 11 C1, right? It's 11 C1. Now extending this logic to this case. Now if you have x1 plus x2 plus xk equal to n, now for breaking the string into k parts, I need to place k minus 1 partitions, right? So I'll have to place a partition here perhaps, here perhaps, here perhaps, one more here, one more here. So likewise I have to place k minus 1 partitions. So effectively, while arranging, can I say I have k minus 1 identical partitions and there are n balls, identical balls. We can think of them as balls, marbles, all right, rings, anything, identical. So overall, can I say I have n plus k minus 1. Overall, I have n plus k minus 1 articles, right, which are to be arranged, out of which n are identical of one type, k minus 1 are identical of some other type. So in how many ways can we arrange them? So basically arrangement of identical elements, we get it as n plus k minus 1 whole factorial by k minus 1 factorial into n factorial, right? Or another way of looking at it could be, observe, another way of looking at this is, now when I say there are k minus 1 partitions identical and n identical balls, overall I have to place n plus k minus 1 objects. Overall I have to place n plus k minus 1 objects. Now out of the spaces, n plus k minus 1 spaces, at any k minus 1 spaces, I can place the partitions. So in how many ways can I do it? N plus k minus 1, C k minus 1. So this is a number of ways in which you can place the partitions. So thus this is also nothing but, when you also expand this NCR, you will get the same expression. So when you're talking about whole number solutions, the answer can either be this or this. Either ways you will get the answer. Now, based on whole number, we can also go to natural number. I'll just share the formula for that. Natural number solutions is for the same equation is n minus 1 ck minus 1. N minus 1 ck minus 1. Very, very easy to explain that also. So if I try to do that, right, let me do it. So if I take a number x1, x2, x10 is equal to some 50. So that means I have 50 identical balls, right? The first ball to the last ball. Now, to divide this string of 50 balls into 10 variables, I need 9 partitions. Also notice, I cannot place the partitions together like this. Because if I place the partitions together, the variable which is coming in between will become 0. But 0 is not a natural number. So partitions cannot be next to each other. Also, partitions cannot come at extremes like this or like this, because then the variable to the left of this or to the right of this will become 0. Not allowed. So that means partitions can only take the in-between values. So if there are 50 balls, how many spaces will be there in between? It's 50 minus 1 or 49. And how many partitions are we to place? So if there are 10 variables, we have to place 9 partitions. So thus the formula is like n minus 1, 50 minus 1, c 10 minus 1, k minus 1. I hope we are clear. I'll just clean this all. Now we'll get to the problem which we are given with. Please make a note of this formula in case you're not aware of this concept. Now if you're aware, then I hope this has helped you recall the formula so that you can use them properly in this question. Now, we have 3 identical boxes. Let's say the boxes are B1, B2, B3. The sum should be equal to what? We are placing 15 identical balls, such that B1 should be greater than or equal to 2, we wrote. So B1 is greater than or equal to 2. What does it mean? B1 minus 2 should be greater than or equal to 0. Let's put B1 minus 2 as small b1. So small b1 should be greater than or equal to 0. Similarly, we may write it as, let's call it as small b2 greater than or equal to 0. And similarly, so let's write as small b3 greater than or equal to 0. Now let's try to convert this equation which is in capital B1, B2, B3 into small b1, b2, b3. The way we do it is simple. You subtract 2 on both sides. You get b1 minus 2, which is small b1. Subtract 3 on both sides. You get small b2. Subtract 5 on both sides. You get small b3. This will be equal to 15 minus 10, which is 5. And for this equation, we simply find out. For this equation, we simply find out the whole number solutions. So what's the formula? The formula was n plus k minus 1. N is 5. K is number of variables minus 1. C k minus 1. So when you solve this, it's 8 minus 1, 7, C2. And 7 C2, when you find the value, 7 into 6 by 2 into 1, it will give you 20. So in how many ways can we do it? So the answer should be 21 ways. Okay, so this was a problem from your permutation combination, right? Placement of identical objects into distinct boxes. So like this is how we can deal with it. I hope this was clear. So on that note, we have come to the end of the video. So for more such videos, right, please subscribe to our channel. Thank you and all the very best.